We did Fourier expansion using trigonometric Fourier series and compact form of Fourier series, where we express as amplitude capital A cosine omega t plus phi. And today we're going to make the complex exponential Fourier series, which is the more general one and mostly used. So how do you express a periodic function? We're still talking about periodic function. How you express it in complex exponential Fourier series? We'll say that the signal x of t, continuous time signal, will be equal to sigma from k equal negative infinity to positive infinity, ck, that's the coefficient of complex exponential Fourier series, e to the power of j k omega naught t. This is the expression, as you see, simple, has only one term, but it's preferred to have c naught when k equals 0, make it separate, so avoid any error can happen. You write c naught, and the rest will be from k equal negative infinity to positive infinity, but k not equal 0, because if you separate it, and we prefer to do that, e to the power of j k omega naught t, and c naught exactly the same value as a naught, so you can write equal a naught if you wish. That's equal to a naught that we did previously, integrating the function over one period. So I'm missing here ck, the coefficient. So how can you find ck, the coefficient ck? It's equal 1 over t naught, that's the period of the function, and you integrate it over one period, t naught, the signal. Before we used to multiply it one time by cosine to find an, multiply by sine to find bn. No, just it's one term only, and you don't multiply by cosine or sine, you multiply by e to the power minus j k omega naught t dt. So observe the difference between ck and when you make the expression for x of t. When you find ck, you integrate the function multiplied by e power minus jk. But when you make the sum, you don't put the minus, you have e power jk omega naught t. So they are so similar when you find the ck and the sum of the exponential Fourier series in this form. That's all. So this is the new formula for Fourier series using exponential. And it makes sense because when we did before trigonometric Fourier series, we have like an cosine plus bn sine. We can prove it that using Euler identity, that e power j theta is equal cosine theta plus j sine theta, if you remember that. So e power j theta, with it in complex number, is equal cosine plus j sine. So that's what they did. And then they found in the end that it can be expressed in one formula like that using exponential function. And that's easy for performing mathematical operation. If you want to multiply x of t by exponential function and integrate it, it's much easier because we know the integration of e power anything, it's the same thing divided by the coefficient. Differentiation of e is the same also. So this is it's easier to use this one. Well, but you observe something that we have from k negative infinity to infinity. So we are going to have like a negative frequency and positive frequency. Negative frequency does not have physical meaning. It's just a mathematical thing. You'll find frequency is equal to 50 hertz and minus 50 hertz. It doesn't have physical meaning. It's just mathematical expression. And what else? Since you have k from negative infinity to infinity, in general, if you can find ck for positive values for k, you don't have to find for negative k because there is a relationship. C to the negative k is the same as c of k but the conjugate. What does it mean? Means if we found ck, and let's say, for example, you found ck and you find k is equal 3 plus j4. In this case, if you want to find c minus k, you don't do the integration in this formula to find no. You just do the conjugate to be equal 3 minus j4. That's if ck complex. Not all cases ck complex. If it's real, what about if it's real? Like equal 3. So it will be equal. The absolute value will be equal. So that's the in general, that's the relationship between c minus k and ck. Using you can find the line spectra. What does mean line spectra? Magnitude spectrum and phase spectrum can be found easily using complex exponential Fourier series. How we'll do that? We know that line spectra has two parts, right? We have magnitude versus frequency, and we have phase or angle versus frequency. The magnitude, you get it easily when you find the coefficient ck, just find its magnitude and then sketch it with against frequency. Some they like to do it against k, because when you say k equal 1, it means fundamental component. K equal 2, second harmonic. K equal 3, third harmonic. So they don't have, sometimes they use omega, sometimes you use f, sometimes use k. All these are possible. But y-axis should be the magnitude of ck. About the phase? The phase, the x-axis will be the same, omega or f or k, and the y-axis will be the angle of ck itself. And we're going to have numerical example how we get it. So that's the application of the Fourier series, the complex one. So it's easy. Find ck. The other one, you have to have an squared plus bn square root. This is just to get the magnitude. So that's really make everything simple. The other thing that we can apply for complex Fourier series, you can find the power continent of any signal. If you want to calculate the power of a signal, we did that before. You can do it using Fourier series, and it's very simple. So the power of any signal x, that will be equal to the sum of k negative infinity to infinity, just the magnitude of ck squared. That's all. It gives you the power. Yes, you give it as a sum, you program it, you do it, and then you calculate it. Again, when I solve problems, I found it's better to separate C0. So I make C0 square, and then I will do the sum. When I used to solve the problems, then I found sometimes you have like number 0.5 over 0.2 plus jk. Then when I put k equals 0, it becomes like something. If it's so, just okay, I'll just do it like that. You can do the formula in general from k negative infinity to infinity. But if you face problem to find the value for c 0, so separate. If you didn't find, go ahead and continue. Well, that's all. So let's just have a numerical example. And I'm taking function, not simple one, not straight line or square wave. That's exponential function, and it's defined over period equal 2 pi. Because if you observe this 2 pi from 0 to 2 pi and repeating itself every 2 pi. So I can say that the period of the signal is equal to 2 pi. That's the first thing we do. And then from that, we can get the angular frequency, the corresponding angular frequency, omega naught, which is equal to 2 pi over T naught. 2 pi over 2 pi in this case is equal to 1 radian per second. So it's easy. All right. The function is given. So I don't have to write it, but I will just write x of t is equal to 3 e to the power minus 0.2 t. And it's defined from 0 to 2 pi. All right. Now, I want to start finding the Fourier series using this new method we explained just now. The steps exactly the same as we did in trigonometric Fourier series. What we start find a naught, an, bn, and so on. So the first thing you do, the coefficient. All right. So let's just find the coefficient. As I said, you can find C naught in the beginning before I start. So I say C naught is equal what? A naught, the same formula that we did before, is equal 1 over T naught, the integration over 1 period for the function x of t dt. In this case, it's 1 over 2 pi, and I'm integrating from 0 to 2 pi. It's only one interval, and the function x of t is given here, equal to 3 e minus 0.2 t dt. So I will have 1 over 2 pi, and 3 is a constant. The integration of the exponential e minus will be the same thing, e minus 0.2 t divided by minus 0.2, and the integration limit from 0 to 2 pi. To get rid of this negative sign on the, I will have 3 over 2 pi multiplied by 0.2, and then I will have e minus 0.2 t. The integration now I flip it because of the negative sign, and then I start substitute. 3 over 2 pi 0.2 is just going to be one number, so I can simplify it here. 3 divided by 2 times pi times 0.2. That's equal to 2.387. And then you start substitute. E power 0 is equal 1 minus e power minus 0.2 times t, which is equal to 2 pi. Again, that e power some constant, I can use my calculator and calculate the value. The C0, I think I did it. Yeah, it's equal to 1.708. That will be the value of C naught or A naught, the same thing. So I did A naught, C naught. Now I will go for general CK. And we'll check that if we can get C naught from CK, it's easy or not. Let's just see. What's CK? Let me review what's the expression for CK. It's the same thing, like when I did A naught, but just I'm multiplying by e power minus g. All right. So I will write 1 over T naught, the integration from 0 to T naught, x of t, e to the power minus j k omega naught t dt. We found out that T naught is equal 2 pi, and we found also that omega naught is equal 1, just to remember. So I'm going to substitute 1 over 2 pi, the integration from 0 to 2 pi, and the function x of t, it's equal to 3 e minus 0.2 t. I'll just check. Yes, it is. And multiplied by e minus jk, and omega naught is equal 1. It's equal 1, so I want t dt. So that's what I got. To do the integration, just let's get the constant out. So you have 3 over 2 pi. I got the 3 is constant, and then I'm going to integrate this thing. Remember, that's exponential is easy. So if you have e to the power of minus a times e to the power of minus b, so what you will do, forget about negative. In general, if you have any exponential, e power x times e power y, what's the result? E power x plus y, right? So that's what I'm going to do. I have e power something, I will add them. When you add them, let me just add first the power. You have minus 0.2 t, and you are going to add minus jkt. So you can take minus as a common factor, and also you can take t as a common factor, because you have t here and there. And what's left inside 0.2 plus jk. So that's your, when you multiply both exponential. So now you can write c of k is equal to 3 over 2 pi. I got the 3 out of the integration. It's a constant. And then I'm going to integrate from 0 to 2 pi e to the power of this thing, minus 0.2 plus jk t dt. So I want to find the integration of exponential. It's easy. What is the exponential? What's the integration of e to the power of at dt? It's equal e to the power of at divided by a. All right. So I can call all the things a. Anything doesn't have t, I'll call it a. All this, I'll call it a. Call it a. So how you integrate? You will have 3 over 2 pi constant, and then e power a, I will just put e power a times t divided by a, and the limit of integration 2 pi 0. And as we read before in the lab project, just we are going to substitute, leaving a in the end, we put a. So you have 3 over 2 pi, and then get a out also, this constant. Then you substitute e to the power at, a 2 pi will be 2 pi a minus e power 0 is equal 1. Okay, now we have it clean. Start to substitute by a, and we know that a is equal to minus 0.2 plus jk. That's a. So I will substitute b equal to 3 over 2 pi. A is equal negative, about the negative out, 0.2 plus jk e to the power 2 pi a minus 2 pi a minus 1. Okay. So what do you have here? 3, you have negative. You can exchange these things, but I can also simplify. 3 over 2 pi can be a number. I will just leave it now. 3 over 2 pi, and then I have 0.2 plus jk. And I remove the negative, so I'm going to change, instead e minus 1 will be 1 minus e. 2 pi 0.2 plus jk. There is no t because we're substituted by t. Well, in the here this 3 over 2 pi times 0.2 plus jk, you can't do anything about it. Just leave it. But I want to look for this exponential. It looks like it can be simplified. So you get it out here and say, okay, what can we do about it? E to the power minus 2 pi 0.2 plus jk equal e power something, like, because we said before, e power x, e power y equal e power x plus y. So I'm going to separate them again. So I have e to the power minus 2 pi times 0.2 will be 2 times 0.2, 0.4. So 0.4 pi. That's the first term. Second term, I multiply minus 2 pi by jk. So I have minus 2 pi, I'll have minus j 2 pi k. Okay. So minus j 2 pi k. Now start to look like it's going to be simplified even more. What's e power minus 0.4 pi? It's a number. Pi is a number, 0.2 is a number. So I will do it in my calculator. E to the power of minus 0.4 times pi. 0.4 times pi. So I got minus 0.2 times pi. Oh, 0.4. Okay, I got 0.2846. That's a number. What about e power minus j2 by k? Now you go back to Euler. Complex number, you're going to use it now. Let me just write like that here. According to Euler, we explained that before, that e to the power of plus or minus j theta, if you're using the top a plus j theta, it's equal cosine theta plus j sine theta. That's the e. If you have use the negative, be the negative. Okay, that's what we know. So according to this, I can say e to the power of minus j 2 by k. 2 by k is theta. So it's equal cosine 2 by k, and I have minus here, so I use minus j sine 2 pi k. Now, what's sine 2 pi k? 0. Yeah. What is cosine 2 pi k? 1. All the time. Would k equal 1? We have cosine 2 pi, cosine 4 pi, cosine, it's always 1. So it's all equal 1. So now I can replace this term by 1. So actually, we can say the whole thing here is equal to 0.2846. The value of the exponential term. So now I'm going back to the formula here, that's ck, to find the final value for it. Now it looks simple. In the beginning, it looks complex. Now it's equal 3 over 2 pi 0.2 plus jk, and I have 1 minus 0.2846. That thing can be simplified because this all number just constant. The only thing has something variable with k, only this bracket 0.2 plus jk, but the whole thing can be done in the calculator to find its value. I did it. So I found that's equal to 0.3416 over 0.2 plus jk. That's ck. That's ck. So if you want to express the Fourier series, the complex exponential Fourier series, I will go back and remind you by the formula. That's the formula. C naught if you separate it plus the sigma from negative infinity ck multiplied by ejk, the same thing, but just with positive. So let's just write it. Now I have x of t can be expressed like that. C naught to get it equal to yes, that's right. 1.708 plus sigma k from negative infinity to infinity, but k not equal 0. ck, I got it 0.3416 over 0.2 plus jk, e to the power positive j, k, omega naught is equal 1, t. So that's the expression for Fourier series in a different form. as we said that the important thing that you can, or the important information that you want to get from Fourier series, whatever form you're using, you want to get the magnitude spectrum and the phase spectrum. That's the most important. That's the objective. You want to know every single component in this signal, what is its amplitude and the shift of the phase shift. That's all. How you get that? Using Fourier series, even if it looks like complex, but use CK. CK, as we said, is going to tell you all information, tell you the amplitude, the phase, everything. How we do that? Find the magnitude of CK, and we find the angle of CK. How can you find the magnitude and the phase or the angle of something like that complex number? You do table, and I'm going to show you that the table is really helpful. Yeah, this table, I'm going just to copy the table, and we're going to fill this table together. Okay. When you look at this table, that's what you do. Make it like vertical, don't make it horizontal. You make in the textbook, make a table like K, but you will not have enough space. There's many calculations. You put the first one K, that's the first, and then you put the expression of CK that you just got it, and you make sure that's the right one. And then write the expression for the magnitude. How you find the magnitude? The magnitude of complex number, the real number stay the same. But if you have a complex, we said to find the magnitude, you find the square value of the real part, the square value of the imaginary part, you add in the square root. That's the magnitude. All right. What about the phase? Okay, if you have a complex number, you want to find the phase. What is the angle of real number at the top? 0. We said that before. If you have real number positive, the angle is equal 0. If negative, the angle is equal pi 180. Because negative 1, it means 180. If you remember the unit circle, 0 when it's on the x-axis to the right, and then when you go, let me just show you that. If you have the unit circuit like that, and if you are here, that's 1, right? If you are here, you are j. Negative 1 minus j. So when you have negative 1, it's 180. So if you have number like that, 5, what is the angle of 5? Let's say CK is equal 5. What is the angle of 5? 0. Yeah, let's call it 5. So 5K is equal 0. If you have CK is equal negative 5, well, exactly, yeah, 180. Of course, you can say 180, negative 180. We'll say 180. If you have CK equal J5, what is the angle? Great, 90. If you have CK minus J5, 270, or negative 9. All right. What about if that CK is equal to 5 plus J5? But before I go to this point, what is the magnitude of CK in this case? If you want to find the magnitude, what's the magnitude? Please go, it's 5. Minus 5. What is the magnitude of CK negative 5? 5. Absolute value of negative 5. What's the absolute value of J5? 5. The magnitude of negative J5? 5. Right. The magnitude of 5 plus J5. Then you got to do the root. You will say square root 5 square plus 5 square. That will be 5 square root of 2. What about the angle? 10 minus 1, the imaginary over the real, and you get 45 degrees. And then you can continue. That's what about if you have something like that? CK equal 5 over 5 plus J5. The magnitude, easy. 5 in the top by itself. Let me make it like that. Negative 5. The magnitude of the top, negative 5, is still on the bottom. That's the magnitude. Yeah, you don't square the J, only the number. If you want to find pi k, you say the angle of the top minus the angle of the bottom. What is the angle of the top and what is the angle of the bottom? In the top, what is the angle of the top? No, again wrong. 180. It's negative 180. The angle on the bottom, 45. So what is the result? 180 minus 45, and then you subtract, you get that. So that's the way how we get the angle of complex number. Now we'll go back to our part. That's CK, and that's the magnitude, and that's the angle. The angle of the top, CK, is equal 0, and the angle of the bottom, it's 10 minus 1 imaginary over the real. K over 0.2. What's 1 over 0.2? 5. So be 5K. That's where you have minus 10 minus 1, 5K. And then you do it. I'm showing you how to do it so you can answer the question. How I do it?
So we just leave the angle as negative 10 first function.
It's negative 10 minus 1, 5K. Yeah, depends on K actually. And the magnitude also depends on K. I'm showing you how you calculate it because I want to know, I want to make sure that you know how to answer questions. But practically, I use my calculator. Like what? Let me first make K note, C note. C note is supposed to put K 0, right? When you put K 0, then you have this number divided by 0.2. Check if you get the A note that we got it before. If you just multiply, divide 0.3416 divide by 0.2. See what we're going to get. Yeah, we got the same thing. Save. Some situation is hard. And I'll tell you how. If you don't have 0.2, you have only JK, then finally you still are dividing by 0, get infinity, and it's not infinity. So, but in this case, it's working fine. So CK, it's equal 1.708. What's the magnitude of this one? 1.708. What is the angle? 0. DC is easy. Now we'll go for K equal 1. For K equal 1, you will have 0.3416 divided by 0.2 plus J1. J, that's it. How you do that? Don't do the formula. Do the formula if you are asked question and you need to do it. But if you want to do it, use your calculator. I'm advising you got to have complex. What I do, I just plug the number using the complex mode in my calculator. And then after I write it down, then I say convert to polar. You divide it, and then you give me the answer in complex in rectangle. I said convert it to a polar. So give me magnitude and an angle. The magnitude, that's the magnitude of CK. The angle is different. In one step. So use the technology. So what I did, that I got the magnitude of the first one, 0.335, and the angle was negative 78. 78.7 degree. But I got that when K is equal positive 1. That's what you do. Don't waste your time and substitute by negative 1, and then you find the magnitude angle. Why? The magnitude of CK is equal the magnitude of C negative K or minus K. So if K equal positive 1 or negative 1, the magnitude is the same, but the angle only will be the different. Why? Because if you remember, I told you C minus K is equal the conjugate of CK. It means you're flipping the imaginary number. Yes.
I'm sorry, I'm not understanding. How did you get 5K for the?
Okay. Look at CK here. Let me write it down here. CK is given as 0.3416 divided by 0.2 plus JK. The angle of CK is equal the angle of the top, the angle of point, which is equal to 0, right? Minus the angle on the bottom. The angle on the bottom, the tan minus 1, the imaginary over the real. So B minus tan minus 1, K over 2 over 10 will be equal minus 10 minus 1, 5K. So that's how you got the magnitude for K by putting K equal 1. And you can check yourself and use it. If you have the calculator, use it and see how we can do it. You'll get rectangular form, then just convert to polar. It give you the magnitude and the angle with the right sign. Because if you want to do that by this expression, and sometimes you are going to use it. Some question you find yourself you're going to use it. How you find the magnitude? You substitute by K equal 1 here, and you get the value. How you find the angle here would be minus 10 minus 1, 5K, and K is equal 1 in this case, so be negative 10 minus 1, 5. And you do it in the calculator, and you get it. Okay. Plus 2, you will have 0.3416 divided by 0.2 plus J2. And you find the magnitude. Also, it's done on the calculator. Find 0.17. That's the magnitude. And the angle give me negative 84.3. And when you want to find for negative 2, just change only the sign of the angle. Keep CK magnitude the same thing. Nothing has changed. Why? Always CK positive. Never be. 2. CK, the magnitude, you'll find it's symmetric, it's an even function. Because if you look at the right side and the left-hand side, you'll find they're the same. For the angle is different. You'll find that it's odd function. When you complete the table here, let me just I complete the table. I found that's equal 0.1136. That's the same thing. 0.3416 divided by 0.2 JK J3. 3416 divided by 0.2 plus J4. That's the magnitude. It's as usual. When K increase, the magnitude decrease, and the angle, they have different rule. Doesn't have to decrease. Negative, positive, 86.84, negative, positive, 87. So you can see that the angle is kind of around 80 and 90, between 80 and 90. Then you sketch, of course, you should do it for infinity. Of course, nobody can do it except in using computer. But usually, we are interested only in the first few harmonics, because after that, you see it's 0.0, it's getting smaller. Let me show you how it looks. The lines, I sketch, what you sketch, how you sketch or you plot line spectrum. You can do that. K on x-axis, absolute value of CK, y-axis, that's the magnitude. Use this column and this column. You get magnitude. Or use K with the last one, you get the phase. I did that, and the result is, see it here. Yes, that's how we got. Look at CK, the magnitude CK. What you observe, it's even function. You have in the middle C naught or A naught. That's on x-axis. Has the value whatever calculated. It was like 1.7 was the highest one. Then that's the at 1, which is the fundamental component, and then 2, the second. And as you see, is decreasing. But observe also that it's symmetric about y-axis. So the magnitude of CK is even function. So one time I got an exam question. I said I give them the values only for the positive. I said C1 is equal C2. Then I asked what's C negative 3. Then they send me email. You forgot to give us the expression. So no, it's used the property. Now for the odd, I mean for the angle. The angle, that's the phase angle. Observe it's odd. What does it mean odd? First of all, at 0 is 0 because DC component doesn't have angle. Always 0, always 0. So look at the fundamental component. It has certain value here at 1, K1. Go at -1, it will be the opposite. It will be the opposite. So if you know the right-hand side, left-hand side, just you flip on x-axis on the other direction. Change the sign or the other. You get it. So you don't have actually to calculate all of them, half of them point. Okay. Well, the last application for Fourier series, what we did, we found the coefficient, we find the exponential, we use the line spectrum. You can calculate the power. The power in the signal cell. What's the expression we just said? We said that in general that the power. Oh, let me show you the expression first. Wait. Yeah, that's how we calculate the power. Well, the power in this expression we just get. There is a guy that he called it Parseval's theorem. So this theorem, how to find the power of a signal using Fourier series. You get the magnitude of the coefficient, square it, add it. That's it. Then you get it. Well, so I want to apply this one to find the power of the signal we just had. We have, as you see, once you find CK, you can get everything. That's the secret, CK. Well, I'll write CK that we got. It's equal to 0.3416 divided by 0.2 plus JK. If you want to find the magnitude, so you will do square everything here. That's square. K square, square root. And if you want to find the square of this value, you square this value. So you get 0.3416 square divided by 0.2 square plus K square. And you leave the square root. So that's CK square. How you find the power? This just said add them. Add them. So from K negative infinity to infinity, 0.3416 square divided by 0.2 square plus K square. That's what you're going to do. When I did that, 0.3416, that would be 0.1167, and this one will be 0.04 plus K square from K negative infinity to infinity. And I did the same thing. I said I'm not going to include, I'll make the zero out. So if you do the zero out, I have the magnitude of it was 1.708. I just square it outside. It's better to separate. 1.708 squared. All right. And this one you can do it, but observe something that you can simplify the sum. This is not affected. That's why I left out. This one here, K here is square. So if you put 1 or -1, 2, -2, it gives the same value, right? So I will just simplify this. I will say from K equals 0 from 1, because I have 0 out. If I don't have 0 out, I'll add from 0 to infinity. And I'll write the same expression, 0.04 plus K squared, and then multiply by 2. So of calculating for positive K, calculating negative K, and I just proved to you that the positive, for positive K and negative K are equal, so just get the positive and multiply by 2. And they have 0 out. That's another advantage. Because if you have 0 inside, you double it, it's not going to be right. It means you double down in the middle. That's why I like to separate. And then this one be calculated by the program for 10 turns, 15 turns, whatever, and you get the power of the signal. So